Alrighty, folks, we back at it. Friday, last thing we talked about was trig inverse, specifically sine inverse, and we were dealing with what happens when we have to evaluate some inverse trigonometry in a quadrant that the inverse trig does not like. And this was the last example when we did, and by does not like, I mean, remember, sine inverse can only return values from quadrants -1 or +1. So if you have to do any work over here in quadrant 2, sine inverse goes, that's too far away. I don't want to go that far to get to my positive values, and it'll reflect that triangle into quadrant 1. If you're doing work over here in quadrant 3, sine inverse says, I don't want to have to go that far to get to my negative values, and it'll bring that triangle into quadrant -1, not quadrant 4, because that would be outside the domain of sine inverse, the range of sine inverse. Sorry, I said the wrong letter. Anyway, it would bring it outside of the range of sine inverse. It can only happen here in quadrant -1. So we said, all right, 5 pi over 6. Yeah, that's way over here in quadrant 2. Sine inverse does not want to play in quadrant 2. So what could we do? We could evaluate sine of 5 pi over 6. So I drew my triangle over here in quadrant 2 at 5 pi over 6. It's a 30-degree reference angle because it's an over 6. Sine here is 1/2. Boom. The question actually says then, what is sine inverse of 1/2? Sine inverse says, all right, what's the closest value to 0 that I could go to so that sine at that angle would give me 1/2? Essentially, it's trying to be lazy. It doesn't want to have to go too far to get to those positive values. And it goes, well, I could just stay in quadrant 1 and sine could be positive 1/2. Boom, there it is. So our answer is 30 degrees or pi over 6. Now, before we do any more examples that are in the notes, I wanted to touch on this idea of what if it's somewhere else, right? The example that I just showed you, you don't have to have this written down, I just want you to see it. The example that I just showed you was specifically one that you could evaluate by hand. But what if it was one you couldn't evaluate by hand? Like this. I don't know. How about that? So over 9, 180 divided by 9 is 20 degrees. So this is a 20-degree reference angle somewhere, which is clearly not one of our special ones, right? It's not a special one. And because this is outside of quadrant 1 or -1, sine inverse and sine cannot just simply cancel each other and tell me that the answer is 17 pi over 9. It doesn't work that way. So what would you do? Well, you could think about where it is and then where sine inverse would want it to be. So let's do it like this. 17 over 9. That's almost 18 over 9, right? Which is equal to 2. So this is almost equal to 2 pi. Almost. So if it's almost equal to 2 pi, what quadrant would it be in? Quadrant 4. So here's what I'm going to do. I'm going to draw quadrant 4. Picture not drawn to scale. This is just so I have something to look at. And I'm going to say from, oh no, here to here, this is my 17 pi over 9. That means the angle on the inside, what's left is a pi over 9, correct? Which is 20 degrees. Pi over 9 or 20 degrees. The question says, what is sine inverse of that? Well, it happens to be in a place that sine inverse likes, right? It just isn't the right angle measurement. But since it landed somewhere that sine inverse likes, I don't even have to move the triangle. I just have to give an answer that sine inverse will be okay with, and that would be negative pi over 9. Because this angle and this angle are coterminal angles. So this is in a quadrant that is coterminal to somewhere that sine inverse is cool with. But what if it hadn't been that? What if it had been something different, like 10 pi over 9? Again, one that we can't do by hand, at least I don't know what sine of 10 pi over 9 is. But I do know what quadrant that's in. Which quadrant am I going to find 10 pi over 9 in? Quadrant 3, because this is just a little bit past 1 pi. So it's in quadrant 3. Again, picture not drawn to scale. I'm just drawing it so I have something to look at. If this is 10 pi over 9, this is 10 pi over 9. The size of that reference angle is a pi over 9. It's a 20-degree reference angle, correct? Okay. But it's specifically a pi over 9 after pi. But in this quadrant, is sine positive or negative? Sine is negative in this quadrant because the y values are negative. Remember, it's y over r. Sine inverse is trying to stay as close to home as possible. Let's say 0 degrees or 0 radians is home. Sine inverse is trying to stay as close to home as possible, but still produce the fraction that this triangle would have produced. So this triangle would have produced a negative y over r, correct? So which quadrant do I need to be in so that I can produce a negative y over r but stay close to home? Quadrant not 4, quadrant negative 1. So essentially it reflects it. I did a poor job of reflecting that. It reflects it to over here. This is still a pi over 9. Oh, that's right. It can't be quadrant 4. It must be quadrant negative 1. So it took the triangle out of this quadrant, moved it to a quadrant that it can work with, but it could still produce the same sine values. This is a big deal to me because questions like this show me if you fully understand what's happening. Your upcoming test is no calculator. I finished writing it last night. It has questions like this on it, where you had no hope of evaluating this by hand. But that doesn't mean you couldn't evaluate the entire thing by hand if you understand how sine and sine inverse work with one another. Another one maybe? See another one? Okay. How about I go with some 5s because who cares? 11 pi over 5 radians. Which quadrant would this land me in? Quadrant 1, because it's a little bit more than 2 pi, right? So does that mean they cancel each other out and the answer is 11 pi over 5? No, because it's not actually quadrant 1. It's like quadrant 5, if you want to think of it like that. It's coterminal to quadrant 1. But in quadrant 1, what would be the size of that reference angle? And you could do it in radians. What would be the size of the reference angle in radians? It'd be a pi over 5. Because it's 1 pi over 5 after 10 pi over 5, which would have been 2 pi. Here's 2 pi. So the answer is pi over 5. Because it's coterminal to a place that sine inverse likes. Okay? So you guys are kind of getting the gist of how that's working? It's asking, what's the closest place to home, home being 0, so that I can still get the exact same sine values. That's what it's saying. Max, what's up? 9 pi over 5? No, 9 pi over 4. 9 pi over 5 is quadrant 4, but sine inverse doesn't exist in quadrant 4. It exists in quadrant negative 1. So if you did it like that, let's go ahead and write it. Because 9 pi over 5 is in quadrant 4, sine inverse is going to hand us back a negative result. This is a single pi over 5 away from 2 pi, correct? So the answer is going to be negative pi over 5. But if I had said sine inverse of sine of negative pi over 5, the answer would have been negative pi over 5. Because that is exactly a quadrant that it works in. Or sine inverse of sine of, I'm going to pick something wacky. Like, I don't know, 7 pi over 16. I don't know. No clue what this is in degrees. No clue. I don't even know if I can divide 180 by 16. But, you know what I do know? I know what quadrant that's in. What quadrant is that? This is quadrant 1. How do I know that? Because 8 over 16 is 1/2. Quadrant 1 goes all the way up to pi over 2. This is just before pi over 2. So the answer to this question is 7 pi over 16. Because that's quadrant 1. Comfortable with that idea? You probably need a lot more practice. I get it. And I have lots of practice. I did a couple different examples with period 1. You might as well see them. One was me showing them the question that we ended with on Friday, which was this one that we already have finished. I was showing them what it does is it essentially takes this triangle, that is the 5 pi over 6 triangle, and reflects it back to here. And then I said, what if I asked you to do something else you couldn't do by hand? Sine inverse of sine of 220 degrees. I even put that one in degrees. So I took the 220 degrees, which is 40 degrees after 180, and I said, that's quadrant 3. Sine inverse doesn't like it, but sine would have been negative here. So it reflected this triangle into quadrant -1, where sine would have been negative. The reference angle is still 40, so the answer is negative 40 degrees. Okay? And then I actually did the two that I just talked to you about. In fact, I just said this to Max. The sine inverse of sine of negative pi over 9 is negative pi over 9, because that's quadrant -1. So they cancel each other out. And here's the 17 pi over 9. Did I do that one with you? Oh, I did 10 pi over 9, and I did 17 pi over 9. So I was just throwing extra examples at you, just so you could see how they work and what they do. All right. This is with calculator. Now, even though your test is no calculator, I still need you to understand how to use your technology. But we'll do part B without a calculator, and then we'll use a calculator to show that we know what we're doing. Because we could do this without a calculator, part B. But part A, sine inverse of negative 0.81 radians. No, excuse me, I'm sorry. The result of all inverse trig is an angle, so this is a side ratio. This is saying that there's a triangle whose y value is negative 81 and the hypotenuse is 100. So negative 81 over 100. Which quadrant would I need to draw that in so that sine inverse could give me a result? For that the y is negative and the radius is positive. No, for sine inverse though. Quadrant. Well, not 4. -1. I'm only drawing it so that you can see what it would look like. Picture not drawn to scale. It would have been like this. I have no clue what that x value is, and I don't care. Yes, Max? This is 81 hundredths. So I just did 81 over 100. I mean, I could have said this was negative 0.81, and I could have said the radius was a 1. It doesn't matter. I just wanted to draw something. But because it's sine inverse, we need this angle to be negative. So we grab our calculator. We make sure it's in radian mode. It is in radian mode. So sine inverse is second sine. And then negative 0.81. We're expecting a negative answer. And it gave us one, negative 0.94 radians. There it is. Because the result of all inverse trigonometry is an angle. Everybody cool? Questions, comments? No? All right. Let's do this one without a calculator. And then we'll use our technology to confirm. Cool? All right. First, 3.49 pi. How many radians are in a full circle? 2 pi. Not 2 radians, 2 pi radians. This is clearly more than 2 pi radians. How much more? (1.49 pi). So it is 1.49 pi radians after 2 pi. Well, as far as sine is concerned, every full circle means nothing. So as far as sine is concerned, you can ignore that part. So then here's my question. Which quadrant would 1.49 pi land in? And think about what it almost equals. It would be quadrant 3 because it's almost a quadrantal. It's almost 3 pi over 2, 1.5 pi. So because it's almost the negative y-axis, which is 3 pi over 2, we know we're in quadrant 3. So I'm going to draw quadrant 3. Picture not drawn to scale. I'm aware that it's almost on the negative y-axis, but I need to be able to draw in the triangle. If this is pi, then what is the size of the reference angle? How far after pi is it? 0.49 pi. So we know that inside this triangle is a 0.49 pi because our 3.49 pi did that, right? Well, actually, it started at 0, went all the way around, but I only drew the 1.49 part. Okay, sine inverse can't play in this quadrant. But in this quadrant, is sine positive or negative? Negative. Which quadrant can sine be negative in so that sine inverse is allowed to play? Quadrant -1. So what we do is we reflect this triangle into a quadrant that sine inverse is allowed to work in, but the size of the reference angle is unchanged. But since I'm in quadrant -1, this, that's purple, is my answer. Negative 0.49 pi. And that was without a calculator. Now let's see what that is. Negative 0.49 pi is negative 1.54. Cool? Negative 1.54 is what we're saying the answer is. I'm going to type it in. Sine inverse of sine of 3.49 pi, closing sine inverse, and getting the exact same answer that's on my paper. And we did it without a calculator. What happened to what 1? The 1.49, this is 1 pi. And there's the other 0.49 pi's. Remember, because half a circle is pi, radians. So there it is. What do you think about sine inverse and the way it moves triangles to appropriate places? Do you think you can pull that off? Even without a calculator? Even if it's not a special angle that you could evaluate trig at? Okay. More than likely, with a lot more practice and doing the other trig ratios, you'll feel more comfortable. Because so far, all we've spoken about is sine inverse. But what about cosine inverse and tangent inverse, right? Well, the good news is tangent inverse its range is exactly the same as sine inverse. Negative pi over 2 to positive pi over 2. Quadrant negative 1 and quadrant positive 1. Except, since tangent is undefined on the y-axis, tangent inverse's range won't include negative pi over 2 or positive pi over 2. But that's just because tangent is undefined there. But it's still quadrant negative 1 and quadrant positive 1. Cool with that? Again, and that's because tangent inverse, just like sine inverse, is lazy. It's trying to stay as close to home as possible, but still capture every positive and negative value that tangent could have achieved. Positive here, negative there. You might be wondering, Mr. M, I thought tangent was positive here and negative here in quadrant 2. Why didn't we just do quadrant 1 and quadrant 2? Well, the answer is because we're trying to stay as close to home as possible. So, yeah, tangent's negative here or tangent's negative here, but this is a lot more work than this. And that's why. Okay, so we're trying to be lazy, trying to stay close to home. Cosine plays slightly differently though, because remember, ASTC. Cosine is positive in these two quadrants, negative in these two quadrants. So the first time cosine would be negative would be quadrant 2 or quadrant 3. But you're not going to go to quadrant 3 and pass quadrant 2 when you could have stopped in quadrant 2. And you're not going to go to quadrant negative 2 when you could go to positive quadrant 2. How come? Well, because isn't it just better to be positive than to be negative? Right? In general. Try to stay close to home and try to stay positive. No. Cosine inverse was only going to let you draw in its range in quadrant 1 and 2. And that's it. Quadrants 1 and 2. So tangent inverse and sine inverse are basically going to play by the exact same rules. Just remember tangent's undefined on the y-axis, so tangent inverse won't produce the y-axis. Cosine inverse, 1 and 2. You got to try to remember that. Cosine inverse is 1 and 2. Look at all these practice questions. Woo! There's 12 there, there's 6 there. The rest of the notes is literally just 18 practice questions. And we're just going to practice and practice and practice. This first one. Do you recognize that this is a rationalized special ratio? Do we see it? You don't recognize it? The dead giveaway is that there's a 2 in the radical and out of the radical. Let me grab Samantha's pass here. Essentially, if you see this, this is rationalized. When those numbers match like that, it's a rationalized version of this. So, you know, tangent and cotangent can give you these, can't they? So if you see that and it's a tangent or cotangent, it was actually that. So root 2 over 2, that's 1 over root 2. And we did that. We rationalized. We went from this side to this side. We rationalized denominators sometime before Christmas. Remember, you just multiply the top and bottom by the no-no. So root 3 times root 3 is root 9, which is 3. So just know that anytime you see the same number in and out of the radical, that's rationalized. Cool? All right. So we're actually reading this as cosine inverse of negative 1 over root 2. This says there is an angle, so that cosine of that angle gives me negative 1 over root 2. What is the very first quadrant that cosine would have given us negative values? Quadrant 2. And that's why we draw this in quadrant 2. The x would be negative 1. The r is root 2. That makes this a positive 1. So then what is the size of the reference angle? What special kind of triangle are we dealing with? Yeah, this is a 45, 45, 90 triangle. So this is a 45-degree angle. Of course, we're going to answer in radians. 45-degree angles are what in radians? They're fourths. So these are pi over 4s. Which pi over 4 do I have here, knowing that this is 1 pi? It's the third pi over 4. So theta is 3 pi over 4. No, the angle, remember, cosine inverse is going to be quadrants 1 or 2. So no negative angles for cosine inverse. Cosine inverse will never give you a negative answer because its range is from 0 to pi. So cosine inverse can never return a negative answer. Okay? All right. This one says there is an angle such that cosine of that angle gets me 1/2, positive 1/2. Well, where's the first time cosine is positive? Quadrant 1. X over r. That makes that a root 3. I just need to know the size of the reference angle. 60-degree reference angle. And we're in quadrant 1. What is 60 degrees in radians? It is pi over 3. 1/3 of a pi. And there it is. It's a basic B questions, right? There is an angle such that cosine of that angle gets me negative root 3 over 2. What's the first quadrant where cosine would have been negative? Quadrant 2. So that's what we draw. We draw quadrant 2. X R. That makes this a 1. What's the size of that reference angle in degrees? This is a 30-degree reference angle. Go Gators, orange and blue. Yep. It's a 30-degree reference angle, but 30 degrees are what fraction of pi? A 1/6 of pi. So this is a pi over 6 here. So if this is pi, and I'm a pi over 6 before that, what is the answer? 5 pi over 6. Because you're going from here to here. 5 pi over 6. So those are just the straight up and down basic ones. So cosine inverse of something positive, quadrant 1. Cosine inverse of something negative, quadrant 2. That's it. Can I answer any questions about the basic cosine inverse stuff? Yeah, Max, what's up? Well, pi over 6 would be in quadrant 1 because that's only 30 degrees. But I'm 30 degrees before pi. So this is pi over 2. So I've already gone 1, 2, 3 of the 6ths, 4, 5, because this is 6 pi over 6. Ready to move on? All right. Boop. What quadrant is 4 pi over 3? Quadrant 3. Cosine inverse doesn't like quadrant 3. Since it's an over 3, what is the size of its reference angle? 60 degrees. But cosine inverse doesn't like that quadrant. In this quadrant, is cosine positive or negative? Negative. Where can cosine inverse get its negative values from? Quadrant 2. So you reflect that triangle up to quadrant 2. Because in that quadrant, I'm going to get the exact same value for cosine that I would have here. the reference angle is still a 60-degree reference angle. And remember, the result here is the angle. That's why I didn't bother filling out the triangle, because the result of all inverse trigonometry is an angle. What angle is this, though, knowing that this is a pi over 3? It's 2 pi over 3. It is a pi over 3 before pi, the blue one is. And that's why it's 2 pi over 3. I didn't even bother filling out the triangle because it doesn't matter. The result of trig inverse is an angle. We simply had to reflect it to the appropriate quadrant. Okay. What quadrant is that? Quadrant -1. In quadrant, quote unquote, -1, is cosine positive or negative? Cosine's positive here, guys, because x is still positive. This is a negative pi over 6, yes? Because it did that. Cosine is positive here because x is positive. Which quadrant will cosine inverse allow me to get my positive values from? Quadrant 1. So this is going to reflect up to quadrant 1, and the reference angle stays the same size. So the answer is pi over 6. And just to prove a point, I put my calculator in degree mode because pi over 6 is 30 degrees. Cosine inverse of cosine of negative 30 degrees is positive 30 degrees. See? It reflected it for me. The result of all trig inverse is an angle, yes? That means pi over 2 is side lengths of a triangle. This is x over r. So what is cosine inverse of pi over 2 going to tell me? That's tangent inverse that you're thinking of, but that's the range, not the domain. This says there is a triangle such that x has a length of pi and r has a length of 2. That's what this says. There you go. This says x is longer than r. This is undefined. Okay, what if I wrote it like this? Where is pi over 2? It's not a quadrant, so you can't tell me quadrant 1 or 2, but where is it? It's a quadrantal, but it's specifically between quadrants 1 and 2, right? Cosine inverse plays between 0 and pi, right? So the answer is pi over 2. Because cosine inverse is comfortable being at pi over 2. It's between 0 and pi. It's in the range of cosine inverse. So they cancel each other, just like that. Just like if it had said cosine inverse of cosine of pi over 6, the answer is just pi over 6. Because quadrant 1, cosine inverse goes, yeah, quadrant 1, no big deal. We're good there. Or if it had said something like this. Where's 5 pi over 6? Quadrant 2? Is cosine inverse cool with quadrant 2? Yeah. Since cosine inverse is cool with quadrant 2, the answer is 5 pi over 6. They just cancel each other as long as you're in a place that the inverse is cool with. All right? Okay. Just watch out for that. Don't fall into that trap. The result of trig inverse is an angle. The input of trig inverse is side lengths of a triangle. That's not possible. Okay? Watch out. How about some tangent inverse? This says there is an angle such that tangent of that angle gets me root 3. But the result of tangent is supposed to be a fraction. The input then needs to be a fraction. What's the rest of this fraction? Over 1. Where will tangent be positive for the first time? Quadrant 1. So I can draw quadrant 1. My y over x, root 3 over 1. It's clearly a 2, so what is the size of that reference angle in degrees? 60-degree reference angle. Then our answer is in radians. What? Pi over 3. There it is. Tangent inverse of -1. What's the rest of that fraction? Over 1. Somebody said it. So we're missing the over 1. Tangent inverse. Where's it going to get my negative range values from? Quadrant -1, just like sine would have. In quadrant -1, quote unquote, the y value is negative. It's isosceles, so, side times root 2, there it is. What's the size of the reference angle in degrees? It's a 45-degree reference angle, but we know because it's tangent inverse, it is opening clockwise. So in radians, our answer is negative pi over 4. Awesome. Feel like you're getting more comfortable with it. This is good. Okay. Y over r, negative. Where am I going to draw this? Quadrant -1. Good. All right. Y is negative in quadrant -1. I think I said y over r, didn't I? I think I said y over r. It's y over x. What's the size of that reference angle in degrees? 30 degrees. But we know because it's tangent inverse, we're doing this. So what is our answer in radians? Negative pi over 6. Good. Do you have questions for me about the basic tangent inverse style questions? Yes, Kelsey. Well, I mean, so tangent is negative in 2 places. Yes, it's negative here, where the root 3 would have been negative, but the 1 would have been positive. But tangent inverse doesn't go this way. Tangent inverse tries to stay close to home. That's why. Okay? If it hadn't said that, if it just said tangent of theta is -1 over root 3, yes, there would have been 2 places that could have occurred. Could have occurred in quadrant 2, could have occurred in quadrant 4. But because it specifically says tangent inverse, our range only allows quadrant 1 or quadrant -1. Okay? How do we feel about that? Yeah? All right. Let's keep it moving. We're doing well. Tangent inverse and tangent want to cancel each other. Is this a quadrant that tangent inverse plays in? Nope. Crap. That means they don't strictly cancel each other. Which quadrant is that? Quadrant 2. All right, so we draw quadrant 2. And we'll throw a 3 pi over 4 reference angle on there. In degrees, what is that? It's a 45-degree reference angle. But you know what? I don't even need to fill out this triangle. Instead, what I need to do is ask myself, is tangent positive or negative here? Tangent's negative here. So where will tangent inverse allow negative inputs? Or, excuse me, outputs? Quadrant -1. That's where the negative outputs will occur for tangent inverse. Because tangent here is negative. So it says tangent inverse of a negative number. That's quadrant -1. But the size of the reference angle doesn't change. It's a 45-degree reference angle. But since it's quadrant -1, we're there. So what is our answer in radians? Negative pi over 4. You didn't have to be so quiet about it, Max. You got this? Yeah. It's negative pi over 4. And this is just like what Kelsey just asked. In this quadrant, tangent is negative, yes. But tangent inverse doesn't allow this quadrant. So it goes to a quadrant where it is allowed to produce negative results. Why is tangent negative? Because one of your variables here is positive while the other is negative. Y is positive, X is negative. So if we fill out the triangle, this would have been +1, this would have been -1. So tangent's -1 here. So this is basically the same thing as saying, what is tangent inverse of -1? Oh, wait a minute. We just did tangent inverse of -1. See? They're the same question. These two are the same question. Okay, this one doesn't say -1, this one says +1. Result of tangent inverse is an angle, right? At what angle would tangent have given me the value of 1? That's what that says. Where would y over r have equaled y over r? I did it again. Where would y over x have equaled 1? In quadrant 1. In quadrant 1, what's the size of that reference angle? 45 degrees. Oh. They're both allowed to be there. The answer is 1. The question literally says, what is tangent at this angle? It's 1. And then lastly, what quadrant is that? 3. Does tangent inverse like quadrant 3? Nope. Size of that reference angle, since it's an over 6, 30 degrees. And since tangent inverse doesn't like that angle, where does it go? Quadrant what? Quadrant -1, because tangent is, you sure? +1. Tangent in this quadrant is positive. So tangent inverse gets its positive results from quadrant 1. The answer then is, in radians, pi over 6. There it is. Boy, we super nerds now.